Hang on guys, let's do this problem right here. It's asking box a box with a square base and open top must have a volume of 32,000 centimeter cube. Find the dimensions of the box that minimize the amount of the material used. In this case, what we have to do is let's draw a sample picture of this one. So let's say this is a box. So it's going to be a box, and it's not perfectly matching with the question, but however they are saying the base is a box with a square base. It means this length and this length are equal. So it means if this is one is x, this is going to be x, and we are going to have a height that's going to be something different. However, then the question is, so they are saying must have a must have open top. So it means there's nothing on the top, and volume of 32,000 centimeter cube. So they are giving the volume. So first of all, we have to know the volume equation is going to be x square h. Since these two have the same width, it's going to be x square h. So this is my volume. Also, they have given the volume is 32,000. So I substitute it here. It's going to be 32,000 centimeter cube. And so that's one of the equations. So let's say this is the equation one. Since they are asking for the for the material use, so we have to in this case we have to use the area to find these dimensions, right? So to find the area, first of all I have to we have totally we have 5 sides. The top side is open, so we shouldn't forget that. In the bottom we have a square base, so it's going to be the area of this one is going to be x square, and area of this side is going to be xh. Since the height times the width, it's going to be xh, and since we have 4 sides, it's going to be 4xh. 4xh, and this is going to be my area. And to find the dimension that minimize this area, I have to find the derivative of this one. I have to find the critical number. So because critical number gives the absolute minimum and the absolute maximum. So to find this, I have to find the critical number. But if you see this equation, we have h and x. So I have to bring this h in terms of x. How we can do that? If you see this equation number one, I can find the h in terms of x by rearranging it, right? So it's going to h is going to be equal to 32,000 by x square. So I substitute this value for the h here. So it's going to be x square plus 4 times x times 32,000 over x square. So from this one, what's going to happen is this x cancels. So it's going to be x square plus 4 times 32,000 over x. And if I take the x common, it's going to become oh, I can multiply, and let's see. So this is area, then if I multiply these two together, I will get 128,000 over x. So my next step is to find the derivative, to find the local maximum and local minimum. So if this is a prime is going to be x square become 2x plus this is x minus 1, right? So it's going to become minus 128,000, and minus 1 minus 1, which is going to become minus 2. So therefore this will become minus 128,000 over x square, because if I take the x value on the top, it's going to be x to the power of minus 1, and if I find the derivative, this minus 1 multiply this 128,000, and that will become minus 128,000. And since this is the formula I'm just n, so if you have x power n, the derivative is going to be n x n minus 1. So the same approach is I am using here to find the derivative of this one. So it's going to be minus 128,000 over x square, and that's going to be the derivative. Then our next step is to equalize this one to 0 and find the x value. So if I equalize this one to 0, and so there's two possible critical numbers, right? In this case, because in critical numbers we had to find the values that does not exist. For example, if I find the derivative and if I divide this one by 0, this does not exist, but that's going to be one of my critical value. But however, we are not going to use it because if you see the dimension should be always greater than 0. You can't have a dimension that is negative, and that can't be also equal to 0. Therefore, this is greater than 0. Since this is greater than 0, this critical number is not in the domain, because if I take the critical numbers, the only possible way this equation does not exist when we divide this one by 0. So but when I take that's going to be one of my critical number, but however that's not going to be a critical number because it's not in the domain, because our diamond should be always greater than 0. Therefore we shouldn't take that. So the other way to find the critical number is to equalize the derivative equals 0 and find the critical numbers. And if I equalize this one and find the x value, it comes out to be, if you solve this, so I use one more step to solve this. So it's gonna be 0 is equal to 2x minus 128,000 over x square. And if you find the x value, you will come up with x is equal to 40 centimeter. And that's going to be my x dimension. And since we find the x right here, we can substitute in the h to find the h value, right? But before I do that, I have to make sure this is local minimum, because this is absolute minimum, because we don't want, because if you find the critical number, there's two possible things. It can be absolute maximum or minimum, so we have to always make sure it's absolute minimum. To find the absolute minimum, the easiest way is to, you can use first derivative test or second derivative test, but second derivative test is much straightforward because it will give you directly the answers. So first of all, I to find the second derivative test, I state the first derivative first. It's going to be 2x minus 128,000 x power minus 2. I got it from here. So we found the first derivative already here, right? So if you divide this divide by x square. So since if I take that one into top, it's going to become minus 2, x power minus 2. Then I have to find the second derivative. So if you find the second derivative, this will become 2 minus minus 2 times 128,000 x power minus 3. So x power, this means 2 plus 2 times 128,000 over x cube. So this means x cube, this means this can be a since this is dividing by x cube, it can be a positive number or negative number. If you have a even power is dividing, for example, if you divide by x square, you can definitely say it's going to be a positive number, because any power, even power square is going to be give you positive value. But since this is x cube, you are not sure it's going to be positive or negative. However, this is a dimension, right? As we mentioned before, it should be greater than 0. It can't be, you can't get a dimension that's negative. So this should be greater than 0. Therefore, we know this is definitely a positive number. Therefore, we know the double derivative positive. Since the double derivative positive, we know this graph is opening up. So opening up, therefore, this is going to be absolute minimum. So if the graph is opening up, this is going to be my absolute minimum, right? So absolute minimum, therefore we definitely know this is the absolute minimum. That's what we want. The question is asking find the dimensions of the box that minimize the amount of the material used. Therefore we know this is the minimum dimension. And since we have found out this is the minimum dimension, I know x is equal to 40 centimeter, I can substitute in this equation to find h value. If I substitute here, I will get h is equal to 20 centimeters. Since they are asking for dimension, we have to show in this way: 40 times 40 times 20 and centimeter. So this is my final answer. I hope you guys like this video. See you next time.